Good morning students. Today we will discuss about coordination compounds or complex compounds. Coordination compounds. Coordination compounds or complex compounds. Complex compounds. So coordination compounds, this is the chapter name. So this is the second year chapter after transition elements. In the next chapter is coordination compounds or complex compounds. So first we will discuss about double salts and coordination compounds. So what is the difference between double salts and complex compounds? So what is the difference between complex compounds and double salts or coordination compounds? So first one is double salts. Double salts are existing solid state only. Solid state. They are dissociates into ions. Dissociated into ions, but solid and in solution state also. The solid state and also in solution they exist. After that, so next one is lost their identity in solution. Lost their identity they lost in solutions, but they do not lost their identity. So properties of these double salts are equal to constituents molecules. So but these properties are not equal to constituents molecules. So after that, so in this metal exists normal valency. So here normal valency, but more than normal valency. This is more than normal valency. So these are the differences, and in between these ionic bonds are there. They exhibit ionic bonds. They exhibit ionic bonds as well as dative bonds, coordinating covalent bonds. Dative bonds also exist. So for this, these are the differences. I will give an example for this. So here, these are the differences, and I will give example. So solid state as well as the solution state, and lose their identity in solution. They do not lose their identity. Properties of the double salts are equal to the constituent molecules. Properties of the complex compounds are not equal to the constituent molecules. Metal exhibit only normal valency. Metal exhibit more than normal valency. So they exist ionic bonds only. They exhibit ionic bonds as well as dative bonds. So these are the differences between complex compounds and double salts. I will give an example for double salts. And so KCl, MgCl2, 6H2O. This name is carnallite. Next one, potassium, K2SO4, Al2SO4, taken thrice, 24H2O. It is also one of the double salt, potassium. Next one, Morse salt. So sometimes they will ask the formula of Morse salt. FeSO4, NH4, taken twice, SO4, 6H2O. The 6H2O is a formula of Morse salt. These are our example for double salts. When they dissolve in the water, they give K plus, Cl minus, Mg plus 2, Cl minus. All ions are dissociated. But in complex compounds, they won't give the ionization. That is the difference. So after that I will give for this K4FeCN6. This is one of the complex compound. It gives only potassium ion. So after that K3FeCN6. It is also one of the important complex compound. After that, so here only D block elements and transition metal ions are can form transition metal ions. Transition metal ions are form the D complex compounds. Why? Because they having small size and high charge. Small size, 3 reasons: small size, high nuclear, high charge, and vacant d orbital. After that, fourth one is they accept the lone pair of electrons. So due to these 4 reasons, D block elements are formed complex compounds. So this is the difference between the double salts and complex compounds. So carbonate is not a complex compound. Potassium ferrocyanide is a complex compound. Potassium alum is a double salt. But this one is potassium ferrocyanide is a complex compound. Like the more salt is not a complex compound. So this is the difference between double salts and complex compounds. So why only transition metal ions, D block element transition metal ions can form the coordination compounds? Because of some reasons, small size, high nuclear charge, vacant d orbital, acceptance of lone pair of electron from the other substances. So due to these reasons, D block elements are formed complex compounds. After that, next one is one theory is there. That theory is called werners theory. So werners theory is explained about the complex compounds properties. The theory is called werners theory. So werners theory. The theory is explained about the properties of complex compounds. So Werner is called as father of coordination chemistry. So he is the scientist father of coordination chemistry or father of complex compounds. His name is. So that's why Werner is known as father of, because he has done so much of work on the coordination compounds. So according to this theory, Werner's theory, coordination compounds, metal ions exhibit 2 valencies, that is primary valency and secondary valency. So one is 1 degree valency and second one is 2 degree valency. So 1 degree valency is called primary valency. This is called secondary valency. So 1 degree valency, primary valency is ionizable valency. It is non-ionizable valency. Therefore, 2 valencies are possible for the complex compounds. So one is 1 degree valency and second one is 2 degree valency. So first 1 degree valency is discuss about 1 degree valency. So 1 degree valency is equal to the oxidation state of the central atom. It is referred to the oxidation state of the central atom. So it is also called as ionizable valency. And it is satisfied by only anions. 1 degree valence is satisfied by only anions. It is intimated by dotted lines in the structure of complex compounds. After that, 2 degree valency. So 2 degree valency is called as non-ionizable valency. So it is satisfied by anions, neutral molecules, and sometimes cations. It is satisfied by ligons. Those which is satisfied by 2 degree valency, that molecule or the substance are called as ligons. Liga. What are ligons? We'll explain later. So ligons. After that, the number of 2 degree valencies is equal to the coordination number of that element. So, coordination number of that complex compounds. So I will give an example for this. And this CONH3 taken 6 times Cl3. So when it is dissolved in water, it gives CONH3 plus 3 plus 3Cl minus. So this is primary valency. So here 6, this is secondary valency. I will draw the structure, and secondary valence is intimated by shaded like this, a thick line. So like this, and it is intimated by dotted individual line. So I will draw the structure here. CONH3, NH3, here NH3 4, 5, 6, here 6. Therefore 1, 2, 3, 4, 5, 6 thick lines. Therefore coordination number of this compound is 6 only. Where intimated this is 2 degree valency, and primary valency is intimated by dotted lines like this. So here primary valency. So that is 3. That is 1 degree valency. This is the structure of CONH3 taken 6 times Cl3. This is about werners theory. According to werners theory, 2 valencies are possible for the complex compounds. One valence is called as 1 degree valency or primary valency. Secondary valency or 2 degree valency is non-ionizable. So 1 degree valency means is equal to the oxidation state of the central atom. It is satisfied by the anions only. It is intimated by dotted individual lines. 2 degree valency is satisfied by anions, neutral molecules, and cations. Which are satisfied the 2 degree valency, they are called as ligons. They are intimated by thick line. So it is non-ionizable, it is ionizable valency. We will observe the structure of CONH3 taken 6 times Cl3. So here 1 degree valence is equal to the oxidation state of central atom. 2 degree valence is equal to the coordination number of the central atom. Therefore, already given here, coordination number is 6. 1 degree valence is 3. This is about Werners theory of complex compounds. We will discuss about more things in the next class about Werners theory and structure. So many structures are there. We will discuss in the next class.